Have you ever wondered how artificial intelligence like ChatGPT seems to actually understand what you mean, not just what you say? Imagine asking a machine, "What is love?" and getting an answer that makes sense. That is not magic. That is the power of vector embeddings, a core technology behind today's most advanced AI systems. Let us start with a simple question. How do you teach a computer the meaning of words? For years, computers only saw words as strings of letters. The word cat was just the letters C, A, and T. But meaning? That was out of reach. This is where vector embeddings come in and why they are so important for large language models, or LLMs. A large language model is a type of AI trained on massive amounts of text to generate human-like responses. ChatGPT is one famous example, but there are many others. These models use vector embeddings to turn words, sentences, or even whole documents into long lists of numbers. Think of it like translating language into math. Each word or phrase becomes a point in a huge invisible space. Words with similar meanings end up close together. For example, cat and kitten are neighbors, but cat and car are far apart. Here is a quick analogy. Imagine a giant map, but instead of cities, you have words. The closer two cities are, the more similar they are. If you want to know how similar two words are, you just measure the distance between them on this map. This is where cosine similarity comes in. It is a fancy way to measure how close 2 points are, no matter how long the lists of numbers are. But why does this matter for AI? Let us say you ask ChatGPT to recommend a movie. The model does not just look for the word movie, it looks for meaning. It finds the vector for your question and compares it to vectors for thousands of possible answers. The closest match wins. That is how it seems to understand you and why LLMs are so good at tasks like semantic search and generative AI. Here's the twist. Not all words are created equal. Some words have many meanings. Take the word bank. Are we talking about a riverbank or a place to keep money? Vector embeddings help sort this out by looking at the context. The numbers change depending on the words around them. This is called semantic similarity. It is how computers get better at understanding what you really mean. Let us pause for a second. Have you ever sent a text that was misunderstood? Maybe you meant one thing, but the other person read it another way. Computers used to have that problem all the time. Vector embeddings are like giving AI a better sense of context so it makes fewer mistakes. Now, here's a list of 3 ways vector embeddings are used in the real world. First, search engines use them to find the most relevant results, even if you do not use the exact words. Second, recommendation systems, like those on streaming platforms, use embeddings to suggest shows you might like. Third, chatbots and virtual assistants use them to understand and respond to your questions more naturally. All of these are powered by the same technology behind LLMs. But there is a challenge. The space of possible meanings is huge. Training a model to create good embeddings takes a lot of data and computing power. The subplot here is the race to make embeddings more accurate and efficient. Every improvement means smarter, more helpful AI. So what is the most valuable insight? Vector embeddings are not just about words. They are about meaning. They are the bridge between human language and machine understanding. As these models get better, we get closer to computers that truly understand us, not just process our words. This is the foundation of the generative AI revolution. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.